Welcome to Shining Pennies and Dancing Kernels, fun and interactive experiments to share with young children. A presentation by the Michigan State University Extension Child and Family Development Team. My name is Kevin Zoromski, and I will be leading you through the video. MSU is an affirmative action, equal opportunity employer. Michigan State University Extension programs and materials are open to all without regard to race, color, national origin, sex, gender, gender identity, religion, age, height, weight, disability, political beliefs, sexual orientation, marital status, family status, or veteran status. Our objectives in this presentation are to increase understanding of the basic scientific process, enhance appreciation and understanding of the importance of science experiences for children, and provide ideas for facilitating science experiments with children. Here we have 3 pennies. This activity is to learn which one we can clean the best. Take a look at each penny. Write down or pay attention to what you see. Which is the dirtiest? A, B, or C? Which one seems the grimiest? Now we are going to prep them for cleaning or for shining. Here you see 3 cups with 3 very distinct different liquids. Cup A is soapy water. Cup B is ketchup. Cup C is vinegar. Here we can observe what each cup looks like and smells like. Which of the 3 will clean the pennies the best? Will it be the soapy water, the ketchup, the vinegar? Here is where we begin discussions, observations, and ideas. We talk about each cup, what they smell like. Which of them do you think will clean the best? Are any of them going to clean? Are any of them not going to work? This is a point where you can talk to your children and just ask them what they think, what will happen. Next is a quick video of placing the pennies in each of the liquids. We will now set the pennies aside and come back to them in a bit later in the presentation. In the scientific process for children, we're now going to discuss and relate it to the children. Observing, predicting, experimenting, interpreting are all a part of the scientific process. We can use everyday language for children to replace the difficult terms. For example, observing can be called watching. Predicting is really just a stage of guessing. Experiment is all about playing. And interpreting is really talking about explaining what happens. Were we right? Did the experiment go the way that we thought? How many times do we really look at something without seeing it or making observations about how it works or affects other things? We need to observe. Observing is all about the questions, what do you see? What is happening? We're going to look for similarities and we're going to look for differences. We'll observe shapes, colors, texture, size. We can practice observation observing. For instance, if we took a pile of Legos, we can work with our kids and list the ways that Legos are alike and ways they are different. They can be alike in color, obviously in size and in shape, but they also can be completely different in size, in shape, in color. It's just something that gives us a good opportunity to talk about something in their world. We can use things like highlighters. Same thing, size, shape, color. What can we do with them? How are they alike? How are they similar? This is ways to practice observation. Predicting is a what type of question. What will happen next? What would happen if you did this instead? Would it be the same if? How will this compare? Are all questions that are involved in predicting. Here's another activity that will let us practice predicting. For this activities, the supplies include a small cup of water, a small cup of soda, generally a clear soda like Sprite or 7-Up, and unpopped popcorn kernels. So we're going to practice making predictions in this activity. What do you think will happen if we drop the popcorn kernels into the soda? What will happen if we drop the kernels into the water? I think that the popcorn kernels will. This is how we're going to lead our questions. In experimenting, the child is going to investigate their predictions. They're going to try it and see what happens, and they're going to record the results. Now let's do the experiment with the popcorn kernels. And we can see first, what happens if we drop the popcorn kernels in the water? Now we're going to pay attention to what we did and what happened. And we're going to move to see what happens when we drop the kernels into the soda. We use Sprite in this example. Now we can see very different results between the two, between the kernels and water and between the kernels and soda. So it's time to interpret. Now that we've done the experiment, what can I interpret? How can we explain the results? So questions may include, why did the kernels rise in the soda? Why did they stay on the bottom in the water? How long will this continue to happen? Will they continue to stay on the bottom in the water? Will they ever drop in the soda? What will happen if we used iced tea, a diet soda, Gatorade, other liquids? In interpreting, we can draw conclusions. We'll talk about what will cause the results to change, what should happen next, and did we develop any new questions, any new thoughts? No, we don't have to give children the answers. Just ask them the questions and allow them to come up with an idea. Science is a natural fit. Children in science are a natural fit, which is naturally curious, and they enjoy exploring things. Science encourages kids to explore their natural world. Science experiences should be hands-on, child-driven, which means we let the children lead us in the activities, authentic, real to their world, using real materials that they come in contact with, active, so back to hands-on, using our hands, using our senses, and especially multisensory. So we talk about what things can feel like, what things can smell like, what do they look like. The role of adults is important. We create opportunities for the kids. We can challenge their thinking by asking more and new questions. It's important that we provide safe environments. Offer them secure materials. So materials that are safe for them to hold on to touch, to feel, and to use in the experiments. And of course, encourage involvement. So encourage them to try new things and do things along with them, be a part of experiments and be a part of science. And safety first. We want to assure that floors don't get slippery, that we have a safe spot to do the activities. We want to watch out for soap in the children's eyes, any materials in their eyes. When we can use safety glasses, it's always important and can be very helpful. We want to be aware of potential choking hazards. We want to be aware of our children's age, of their development, so we have safe materials. We want to give safety instructions for using tools, using instruments, so we don't just hand them something and expect that they know how to use it. We have to show them, we have to teach them, and we have to be there and watch them and guide them. We need to be aware of potential allergies. Many children are allergic to latex. Do they have food allergies? So we're going to go back to our pennies. We're going to observe them. Now let's get back and think. Do you remember how they looked? Did you pay attention to how dirty they were? Which ones you felt were the dirtiest? Do you remember the materials that we were using? So what about the substances? Which do you think will clean pennies the best? Do you think it was the soapy water, the ketchup, or the vinegar? Now, let's compare the pennies. So we're going to get the pennies in a new video and we're going to watch and see which one came out the cleanest. So in predicting where your guess is correct, which substance cleaned the best? We look at A, the soapy water. It's a little bit cleaner, but it's still relatively about the same. But if we look at B, the ketchup, we have a significant cleaning difference. The penny looks significantly better. Also in the vinegar, penny looks significantly better than it started. Very clean. So B and C, ketchup and vinegar, were the best cleaning solutions. A, the soapy water, did not do quite as good of a job. Now, let everyone know, when we put them in the materials, in the soapy water, in the ketchup, in the vinegar, we don't shake the bottles or the tubs. We just let the pennies soak in them for about 10 minutes. Now, as we're learning, we're going to ask new questions. Can we start the cycle over again? Could we try other substances? So what else might we be able to use? Could we use a steak sauce? And could we use salad dressing? What kind of salad dressing could we use? So there's many other substances you can try with. And we just want to think about what'll happen if. What if we do try these other substances? And what can we do to make the change? What can we add to it? Could we use water with pepper or salt and shake it? If we shook each of them, would any of them clean better? But the idea is to lead to more questions and to understand why the soap didn't clean as well as the ketchup or the vinegar. Is this something that we can research? Can we go online? Can we learn about? So beyond just doing the experiments, the idea is let's take it to the next step. Let's explore with our kids and find out why. Why did things happen the way they did? And if you were right and you chose the right substance, that's wonderful. But if you chose the substance that wasn't as good, say the soapy water, it's all about researching why the soapy water didn't work as well as the ketchup or the vinegar. So who can teach science? Someone who is willing, can nurture and encourage, so stay positive, is not afraid to fail, because not every experiment's going to work the way that we want it to, is not afraid to get dirty. But of course, just in those examples, you have to be able to reach in the soda, reach in the ketchup and the vinegar, and can listen first. So I was willing to ask those questions and listen to the ideas or listen to the things that they want to try next. So in other words, anyone can teach science. I would like to thank you for viewing our video, Shining Pennies and Dancing Kernels, fun and interactive experiments to share with young children. If you do have any questions or any comments and would like to contact, please feel free to email me, Kevin Zoromski, at zoromski@msu.edu. I will leave the screen up for a second. And I want to thank you for stopping by, checking out our video. Hope you enjoyed the activities and feel free to try them at home. And remember, do it safely, watch our kids and just have fun with them.